Hello friends, welcome again. Today we'll be doing a question related to network analysis, and the question is, here we are given a two-port network and hybrid parameters are given to us, and we are asked to find the maximum power transferred that can occur for a load R. Okay, so first we need to find the value of R. Okay, and then we need to find what is the maximum power that can be delivered. Okay, so how to proceed for this kind of question? So you know that in a two-port network, as shown here, with the voltage and current polarities, we can write the equation for hybrid parameters as V1 is equal to H11 I1 plus H12 V2, and I2 is equal to H21 I1 plus H22 V2. Okay, so here the parameters H11 is 3, okay, H12 is 5, H21 is 1, and H22 is 2. So this equation we know. Okay, so what we can do is we can substitute this parameter and form the equation. So we get V1 is equal to 3 I1 plus 5 V2, and I2 is equal to I1 plus 2 V2. Okay, so these are the equations that we get. So once we have these equations with us, what we can do is, okay, let's see, we can find the Thevenin equivalent across 2 dash. Okay, and once we find the Thevenin equivalent across 2 dash, what we get in Thevenin equivalent is VTH and RTH. Okay, and then what we can do is our maximum power will be transferred when the resistance is equal to the RL is going to be equal to RTH. Okay, so this is how we are going to approach this question. Okay, so let us proceed. Okay, so first what we are going to do, we are going to find the Thevenin equivalent. Okay, so first let's find VTH. Okay, so voltage VTH we need to find. Okay, so what we do when we are finding a Thevenin equivalent, we remove that branch. Okay, so we will remove this RL which is connected across 2 dash. Okay, which is shown here. Now you can see here that we have to find the voltage V2. Okay, okay, if we find the voltage V2, that is going to be our Thevenin equivalent voltage. Okay, so here V2 is equal to VTH, we can write like that. So how to proceed? So here you can see that I have removed the resistance RL across 2 dash, so no current is going to flow across 2 dash, so I2 is going to be 0. Okay, so my I2 is 0. Okay, and my input V1 is 10 volts. Okay, so I can substitute this in the equations here. Okay, so V1 I can put as 10 is equal to, okay, 3I1 plus, okay, 5 V2. Okay, so this is what I can write. Also in the second equation I can write I2 which is 0. Okay, so 0 is equal to I1 plus 2 V2. So from here what I can do is I can substitute I1 value in terms of V2. Okay, so I1 is equal to minus 2 V2. Okay, now I can put it in equation 1. Okay, so in equation 1 when I put, I get 10 is equal to 3 into minus 2 V2. Okay, this is the value of I1 which I substituted, plus 5 V2. Okay, so from here if you calculate V2, that is going to be minus 10 volts. Okay, so this V2 is equal to VTH. Okay, is equal to minus 10 volts. Okay, so this is what I get. Okay, so I have got my VTH now. Once I get my VTH, what I will do is now I'll try to calculate my RTH. Okay, so let us see how to calculate our RTH. Now to calculate our RTH, what we will do is, mm, what is the way to calculate RTH is, all the voltage sources you have to uh, uh, you have to put equal to their equivalent impedance. Okay, so here the input voltage source we will put it as a short circuit. Okay, so we put it as a short circuit here, and we'll try to calculate our resistance B by calculating the ratio of V2 over I2. Okay, so what we do is V1 is now made 0. Okay, see here by this red wire is connected across V1. Okay, so this V1 is equal to 0. Okay, is equal to 3i1 plus 5v2. Now what I can do, I can write I1 I1 in terms of v2. So I1 is equal to minus 5 v2 by 3. Okay, so this I can put in the equation 2. Okay, call it equation 2. So I2 is equal to minus 5 v2 by 3 plus 2v2. Okay, so I2 over V2, if I calculate here, what I get? Okay, let us first simplify it. So I2 is equal to minus 5V2 plus 6V2 by 3. Okay, so from here you see that I2 is equal to V2 by 3, or V2 over I2 is equal to 3 ohms. Okay, so this is going to be my RTH. So now I have my VTH and my RTH. Okay, so what I need to do now is to find the value of RL such that maximum power flows across RL. Okay, so now let us proceed. So now I'm drawing my Thevenin equivalent. So this is my Thevenin equivalent. Okay, I can say this as VTH. Okay, it was minus 10 volts. I am just reversing the polarity. This is VTH. Okay, and this is my RTH, which is 3 ohms. Okay, now what RL should I connect? That should, according to maximum power transfer theorem, this RL should be equal to this resistance 3 ohms. Okay, so it is 3 ohms. Now I have my RL. Now what I can do is I can find either voltage or current through RL and calculate my power. Okay, so let us find voltage. So voltage will be equal to half, because half, both the resistances are same, so voltage drop will be equal across the two resistances. So if I say VL, okay, which is the voltage drop across RL, that is going to be 10 over 2. Okay, which is going to be 5 volts. Okay, now I got my VL. So power transferred is equal to VL square over R. Okay, so it will be 5 squared over 3. So this is going to be 25 by 3, which is 8.33 watts. So my power transferred, okay, power transferred is equal to 8.33 watts. Okay, so this is how you can solve this question. Okay, so thanks for watching.